May, June 2017, paper 3, variant 1. Question 1. The student measures the depth of the water every minute. State 2 pieces of equipment that she uses. The depth of the water every minute. Stopwatch is correct. Okay, definitely. I need the stopwatch. But measuring cylinder is wrong. Measuring cylinder is wrong. Ruler. Thank you. I need a ruler. Not a measuring cylinder. She did not say I need the volume. They said I need the depth. Whenever I say the depth, I mean I need I need a ruler. Thank you. Okay. Next question. Student records her observations in a table. Then she plots a graph using the axes shown. On figure 1.2, label both axes with the title and unit. With the title and unit. What do you think we should label these axes? This is not a paper 6 question, don't worry. It's not a paper 6 question. X-axis is time, correct. What's the unit of the time? He said, the unit of the time is every minute. Definitely the unit of the time slash minute. What about the y-axis? The depth. So it's probably depth in centimeters. This is correct. Okay, thank you. Do not forget the units. The water rises at a constant rate. Draw a line to show the student's graph. Start the line from when the jar is empty. Definitely, when the jar was empty, the time was 0, the depth was 0. It starts from the origin. It rises up at a constant rate, at a constant slope, a straight line. With what gradient should we draw it? Whatever gradient you like. Whatever gradient. All you need to do, straight line using a ruler, and that's it. That's it. Probably the simplest 2 marks you can receive. Okay? Any questions? Okay. Next question. Next question. How can I find the depth? How can I find the depth? The average depth of the water is 2.5 millimeters. Puddle of water. I need to just convert this depth into meters. How can I convert from millimeters into meters? How can I convert from millimeters into meters? Divide by 1000. Yes, thank you. From millimeters to meters, all I need to do is divide by 1000. So this would be 0.0025. Okay, 0.0025. Any questions? Any questions? Please, if you have a question, do not hesitate to ask. I have 3 racing cars, A, B, and C. A and B are drawn. State the maximum speed of A. What is the maximum speed of A? It's quite easy. Maximum speed of A is... يلا يا شباب. What's the maximum speed of A? I know you know it. It's quite... Maximum speed of A is... Yes, 35 meters per second. Okay. Calculate the distance traveled by car B when accelerating. While accelerating, can you find the distance traveled? يلا, tell me. How can I find the distance traveled by car B?
area under the graph اللي هي هتبقى triangle
Okay.
وهتبقى 20 times half times ال height بس أنا مش شايفه.
Half times base times height. Okay. Car B, when accelerating, it was accelerating.
مش 20 ثانية واحدة.
25.
15
This is 15. Yes.
15 times 25 times half.
Okay. Which would give me a total
ثانية.
distance of 187.5
187.5.
meters. Okay, good. Car C has a greater acceleration than car A, but it reaches a lower constant speed than car B. Greater acceleration, but it reaches a lower constant speed. How can I solve this? How can I show him that it has a greater acceleration, but at the same time, it reaches a lower constant speed than A? Hmm, than B.
تبقى steeper أو السلوب هيبقى steeper بس هيبقى أوطى.
Okay. Steeper slope than A, which is correct. Steeper slope than A. So I'll draw a straight line, which is steeper than A. But it will reach a lower constant speed than B. For example, it could reach 20. What if someone says it will reach only 15? It's okay, whatever. It reaches 22. Again, I don't care. Okay. And then I'll draw a constant slope. Okay, horizontal line. I'll just draw a horizontal line, and that's it. This is C. Okay. Hmm. Any questions? Any questions? Yeah. The mass of the tire is 15 kilograms. Calculate the weight. Weight equals, weight equals mg. Yep. Weight equals mg. The mass is 15 times g, 9.8. 15 times 9.8 is 147. 147 newtons. Okay. The, the weight of the tire exerts a moment. Explain what is meant by the term moment. What is meant by the term moment? What do I mean? What do I mean by the term moment? Can someone remember? Huh. It is the turning, yes, thank you. It is the turning effect, not the amount of force acting. I just need to say it's the turning, yes, turning effect. Okay, it is the turning effect of a force about a pivot. You can just say turning effect, that's it. Okay. How can I calculate the moment? The weight of the child and the tire together is 425. Calculate the moment of this force. Moment equals force times perpendicular distance. What's the force? 425. What's the distance? 2.5 meters. Yeah, I need the unit. I need the unit. 425 times 2.5 would give me a total moment of 1062.5 or 1063. It's okay. 1062.5. What is the unit? It has to be what? It has to be Newton dot meter. Okay. Newton dot meter or Newton meter. You can say Newton meter atom or Newton dot meter. It is okay again. A heavier child wants to sit on the tire. Describe how the tire position should be adjusted so that the moment is the same. I need the moment to be the same, but the child is much heavier. Okay. Hmm, what do you think?
Closer to the pivot.
Yes, you are all correct. He has to be closer to the pivot. I need to decrease the distance. Okay, you should decrease the distance to decrease the moment. Okay, smaller perpendicular distance, correct. Um, okay, they store some energy. State the terms used to describe the energy stored. in the reservoirs. What's the energy stored? What type of energy is stored inside the reservoirs? والله يا شباب GPE correct. Gravitational potential energy. Thank you. Gravitational. Okay, again, do not write down GPE. Write it down. Gravitational potential. Okay, energy. Describe how the energy stored in C becomes useful in the hydroelectric station. In C, how does it become useful? We note. The gravitational potential energy has to convert or has to transfer to kinetic energy. Yes, gravitational potential energy transfers to kinetic energy while moving through the pipe. When it moves through the pipe, what happens? This rotates a generator. You have to say it rotates a generator. Yeah. This rotates a generator. Okay. When this generator is rotated, what happened? I'm sorry, it rotates a turbine. I'm sorry. It rotates a turbine. Okay. This rotates a turbine. This turbine rotates a generator, which rotates hmm, a generator. And then this generator produces producing electrical energy. Okay, quite easy. Hmm. Some of the stored energy is wasted. Definitely, we have some wasted energy. Where do you think this wasted energy goes? Or what happens to this energy? Hmm, hmm. You have to state the type of energy and you have to state where is it lost? Where is it dissipated? Definitely, definitely. Yes, someone said it. Correct. It is lost as thermal energy. It is lost as thermal energy to the surroundings. It is lost as heat energy. Both of them are correct. Hmm. Heat energy to the surroundings. Excellent. Water from A and B may flow into C, but it's more efficient to fill C using water from B only. Okay. I can fill up C using B or A, but it's more efficient. It's more efficient to use only B. Why is it more efficient to use only B? It's a really interesting question. Why is it more efficient to prevent? Okay. Any other ideas? Okay. Hmm.
عشان هو في بي هي يعني في ايه هيعمل له بومب هتبقى انرجي اكتر مور انرجي نيد عشان هو اصلا اوطى من سي او نفس الليفل. اما في بي هو هينزل بس.
Okay. بالظبط. Correct. Okay. All of you are correct. يبقى definitely because A requires a pump, but B wouldn't require this pump. B would flow naturally into C. Name a force that prevents a person from slipping. What's one force that could prevent a person from slipping? Okay. Someone can't understand the last one. Okay. Again, A will use a pump. You will use energy. You will use electrical energy to move the water from A to C. It will not flow normally. You need to use energy to produce energy again, which is counterintuitive. Okay. So if I use the pump to pump the water from A to C, I'm using energy, so I'm wasting a lot of energy. But B will flow on its own. You don't need to use a pump. You don't need to use a pump from B to C. You can just open the pipe and the water will flow. Okay? ماشي. Name the force. Yes, you said friction. All of you said friction. Correct. It is, yeah, friction. Hmm. You have a question?
مستر هي تنفع ريزيستنس؟
Resistance?
اه
Um, no, 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 no. Friction.
يعني هي فريكشن.
Friction. Only
تمام.
friction. Okay. Next question. The stool has a round non-slip pad fitted to the bottom. Okay. It has four legs. Each area is 3 centimeters cubed. The weight of the stool is 75. The student sitting on the stool is 525 newtons. Calculate the pressure. How can I find the pressure? How can I find the pressure? Hmm. First of all, pressure equals, yes, force over area. Total force, total force is equal to what? Is equal to both weights added together. So 75 plus 525, which will give me a total force of 600 newtons. Total area, we have 4 feet or four legs. Each leg is 3 centimeters. 4 times 3 is 12 centimeters. So total force is 600 divided by 12 should give a total pressure of 50 newtons per centimeter squared. Okay? Yeah. Good. Hmm. Any questions? Jared, do you have any questions? Yeah. Explain why the stool leg without the pad does more damage to the floor. Why does it do more damage to the floor? Hmm. Area decreases, so the pressure increases, correct? You're all correct. Smaller surface area, correct? Smaller area in contact, correct? Um, try to avoid surface area. Okay, try to avoid surface area. Always say area in contact. Don't say surface area. Say area in contact. So less area hmm, in contact with the ground increases the pressure. Thus, the pressure increases. Okay. Hmm. The metal changes from hot liquid to cold solid. Describe what happens to arrangement, separation, and motion as it changes from liquid to solid. Arrangement, separation, and motion. Three things. Hmm. Arrangement. What happens to the arrangement? What happens to the arrangement? It was something and it became something else. Hmm. Arrangement. It was irregularly arranged. Yes. Irregular to regular. What about the separation? Okay, or regular, or you can say fixed. Yes, someone said fixed. Okay. What about the separation? Okay, the separation, it was further apart. Okay, just slightly further apart, and now they became closely packed. You can say loosely packed to tightly packed. Okay, yes, loosely packed to tightly or closely packed. Tightly packed. Okay, correct. What about the motion? That's easy. We know the motion of of the liquids. The motion of the liquids was sliding, you know, sliding over each other to vibrating. Yes, vibrating in fixed place. Good. Yeah. Any questions? Some water is spilled on the floor. Vibrate in fixed place. Don't have to say fixed place, but vibrate in place. Some water is spilled. Okay. What happens to the water? Okay, it becomes dry. What is this process called? We know this process is called what? The evaporation. Huh? It's called evaporation. What happens in the evaporation? We know that in evaporation, what happens? Water, you have to say, the most energetic molecules escape from where? From the surface. Okay? Most energetic molecules. Hmm. Escape hmm, from the surface, leaving behind the least energetic molecules. But you have to say that the most energetic molecules escape from where? From the surface. Okay. The second part, which is leaving behind the least energetic molecules, causing the average temperature to decrease, we don't really care about it in this question. Why? Because eventually the water will become, or the floor will be dry. I'm not asking whether the liquid will become cooler or not, or why does it cause a cooling effect. So you do not need to state it in this question. Okay. Complete figure 7.1 by adding the two missing labels. What are the two missing electromagnetic waves? Radio waves, microwaves, infrared, visible light, and then two other very simple waves. What are they? Ultraviolet, okay. Ultraviolet and يلا. What else? X-rays. Okay. Thank you. Complete figure 7.1. State the use for one of the uses of the infrared radiation. Hmm. What's one use of infrared radiation? Can you remember? Infrared radiation, we always use yes, the remote control. Thank you. Remote control. Describe the harmful effect of the microwaves on people. Harmful effect of microwaves on people. Microwaves, okay, like the infrared rays, okay, they're both similar in their harmful effects, in which they can cause heating effects. Okay, yes, heating. They can cause skin burns. Okay, skin burn, or you can say heating effect on the skin, for example, whatever. Okay, الميكروwaves and the infrared, they do not cause cancer or mutation or okay. They don't cause the cancer or the what do they do? They cause skin burns or heating effects to the skin. Okay. Hmm. Any questions يا شباب? Any questions? Yeah. Iodine 131 is a radioactive isotope. Determine the number of neutrons. How can I find the number of neutrons inside iodine? It's very simple. 131 minus 53. I guess you all know this one. 131 minus 53 is 78. Beta particles and gamma rays are ionizing radiations. Explain the meaning of ionizing radiation. One of the usually forgotten definitions. You tend to forget, what does ionizing mean? Ionizing means what? What is an ion? Again, what is an ion? It's an atom with more or less electrons. Okay. So basically, whenever I say ionizing radiation, someone said it's the radiation that removes electrons. Yes, it's the ability to remove electrons. Okay. removing electrons. That's why the alpha is the strongest or the most ionizing one. Why? Because it has a charge of +2. It can remove electrons from neighboring atoms. This is the decay for iodine. Determine the half-life of iodine. Yeah, it's quite easy. 3 marks. 3 very simple marks. What should I do? Initially, I'll take the first count rate. 32,000 divided by 2 should be 16,000. What should I do? Using the 16,000, I'll draw a horizontal line and then a vertical line to give me a half-life of 8. That's it. Literally, that's it. Any questions? Any problems? Okay. Different radioactive substance has a half-life of 120 hours. 120 hours. Calculate the time for it to decay to 25% of its original amount. 25% of its original amount. How long should it take? I need someone to help me out. How long should it take? What should I do and why? Any ideas? If it has a half-life of 120 hours, how long should it take to reach 25% of its original amount? No one? Okay. 25%. Okay. Initially, what do I start with? I start off with 100%. Anything in the world starts with 100%. After one half-life, what will happen? I divide by 2, so it becomes 50%. And then after another half-life, it would be 25%. Each of these half-lives takes a time of 120 hours. What do I mean? Okay, I'll draw a simple table. This is time, for example. This is the time, and this is the percentage. I started off with 100%. At time 0, I still haven't started the experiment. At 50%, I took 120 hours. At 25%, 240 hours. Each time I divide by 2, I add 120 hours. I divide by 2 again. I added 120 hours again. So the total time was what? Was 240 hours. Okay? It's a new question. Okay? We don't have many questions like this one. So please make sure you know how to solve it. Okay? Good. Figure 9.1 shows the position of a man working on a rock. A single explosion is used to break part of one rock of one face. Okay. Explain why the man sees the flash before he hears the bang. Definitely, he sees the flash before he hears the bang. Why? Because the light travels faster than sound. Correct. Yeah. Light travels faster than sound. The man hears a second bang shortly after his first bang. State the name given to the second bang. What's the name of the second bang? Second bang is, after a short while, it's called what? It's called an echo. صح? It's called an echo. Yes, it is called an echo. State how the second bang compares with the first bang. I like this question. In terms of its amplitude and its speed. In terms of the amplitude and the speed. Same. لا, it's not the same amplitude. It's a lower amplitude. Lower amplitude. but it's the same speed. Why is it the same speed? It's the same wave. It's the same wave. It went all the way to the cliff and came back, so it took the same it's the same speed, but it has this lower amplitude. Your question is why does it have a lower amplitude, صح؟
لا طب
Hmm.
لو الفريكونسي كنا هنقول lower ولا the same؟
Frequency, it could be the same.
اوكي تمام شكرا.
Could be the same frequency. But definitely the amplitude is lower. Why? Because the sound is quieter. It's a bit quieter. The man stands 170 meters from the back. Okay. The time between hearing the first bang and the second bang is 1 second. Use the information to determine the speed of the sound. How can I find the speed of the sound? How can I find the speed of the sound? This is an echo. This is an echo. Finding the speed of the sound in an echo is distance over time. You have to multiply the distance by 2 distance over time. So the distance was 170 meters, 2 times 170, divided by time, which is 1 second, 340 meters per second. Why? Why did I multiply by 2? That's the question. Why did you multiply by 2? Because what happens is that sound travels all the way to the rock and then back to the man. So the distance is 170. It took 170 meters going to the rock and 170 meters going back to the man. Okay. That's why 2 distance over time. Any questions? Okay. I have some magnets, a strong magnet and a small magnet. Explain why the small magnet is in the position shown. Why is the small magnet in the position shown? Any ideas? Why is it pulled? No one? Hmm. Seems like you've forgotten this part. Okay, well. Hmm. Hmm.
السترون ماجنت عمل للماجنت السمول اتراكت.
Is بالظبط attraction. صح؟ Attraction because they have opposite poles. Okay, attraction due to opposite poles. Attraction due to opposite poles. The strong magnet is turned so that the opposite surface is now facing the small magnet. What happens, if anything, to the small magnet? Would something happen to the small magnet? Would something happen to the small magnet if I faced it the other way around? Definitely something will happen. The magnet will fall. Small magnet will fall because they are now repelling each other. Describe a method for magnetizing. Magnetizing, you're not required to know how to magnetize and demagnetize magnets. Okay. Explain how you would identify the poles of the magnet made in BI. How would you identify the poles of the magnet using another magnet? Okay. Using a pole, okay, of another magnet. Okay. If you have a pole of another magnet, if you have, for example, a north pole of another magnet, if it attracts, then you know that this is a south pole. If it repels, then you know it is a north pole. Okay. If it attracts, okay, opposites will attract and similar poles will repel. Hmm. Any questions؟ يلا يا شباب. يلا. يلا. We're almost done. Almost done. When the switch is closed, now I have a power supply, I have a thin resistance wire. When the switch is closed, energy is transferred from the power supply. Explain what happens to this energy. The energy transferred from the power supply. What happens to this energy? Hmm. What happens to the energy? Any ideas? Hmm. I have some energy inside the power supply. If it was a battery, for example, it would have been chemical energy. What happens to the energy from the power supply? It goes into the thin resistance wire. يلا يا شباب. Goes into the thin resistance wire. Resistance. What does the resistance wire do? It converts this energy, converts this electrical energy, for example, to what? To heat energy. Whatever resistance, it converts it into what? Heat energy. So it's converted to heat energy, which is lost, lost to the surroundings. Okay? A student wants to determine the resistance of the wire. He adds components to the circuit. He measures the current. What's the name of the component that he uses? Definitely, if I want to measure the current, the component I will use is the يلا ammeter. Ammeter. State the name and the function of this component. Ah, do you remember the name and the function of this component? Any ideas? يلا يا شباب. What's the name and the function of this component? Okay. This is the variable resistor. Variable resistor. What does a variable resistor do? What does a variable resistor do? Yes, it controls the current. Controls the current. Okay? Okay, yeah. Last question. Soon demonstrate electromagnetic induction. Okay. Electromagnetic induction. Describe how to demonstrate electromagnetic induction using a magnet, a coil of wire, and a sensitive ammeter. What should I do? Okay, if I have a coil, okay, a sensitive ammeter, what should I do? I need to induce current using a magnet. How should I do it? Very simply, I have an ammeter which is connected to a coil, and then I have the magnet, north and south, for example, and this magnet will start to move to the left. What happens? Okay, what happens as the magnet moves? Okay, we need three keywords. Three keywords as the magnet moves. What are the three keywords? First of all, you have to say the magnetic field. Okay, the magnetic field lines cut, okay, which is the second keyword, cut the coil, cut the coil, producing or inducing a current in the coil. Okay. Again, three keywords. Magnetic field cuts and then induces. Magnetic field cuts and then induces a current. Last question, state two factors that affect the size. The size of the electromotive force, the size of this induced current. How can I increase or decrease the induced electromotive force? I need to speed. Okay, you can change the speed of movement. Yes, speed of movement. And then the strength of the magnet. Okay, and you can say the number of the coils. Okay, any two of these three. Okay, great.